Hello and welcome to my video about the kinematics equations. If we're talking about uniformly accelerated motion, we can actually use any one of the formulas below. So there are a few different values that we have: velocity initial, velocity final, acceleration, displacement, and time. Now, in the last video that we looked at the first one of these kinematics equations. We looked at this part. Okay, and I actually did mention that you should look at this part, which is velocity final minus initial. Okay, the benefit of looking at that is because what you're going to start to notice is if you label all of the different values, so velocity initial, final, displacement, time, and acceleration, all 5 different values, each one of these equations is missing only one of those values, which means that we can solve for the other ones if we have 3 of these values. So we only require 3 values. Okay, so depending on which one you're missing, that's going to determine the equation that you're going to use. So for example, the first one is missing displacement, the second one is missing velocity final, the third one is missing time, the fourth one is missing acceleration, and the fifth one is missing velocity initial. So they're all missing a different variable. So whichever one's missing, that's the one that's going to affect which equation to use. So what do I mean by missing? Well, in some questions, we aren't given the velocity initial, okay? But we're looking for time. So we're not given either of these values, so they're both unknown. But what I do is I go, well, time is the one I'm looking for, so velocity initial is just, I don't care about it, which means we'd use this bottom equation. So that is what I mean by missing. So we're going to be trying a question like this in a moment. But basically, look at which value is missing, and that will determine your equation. The thing is, you're going to have to rearrange the equation to solve for the value that you're actually missing. So, for example, if we are looking for time, and maybe it's this equation here, you have to rearrange it to get time by itself, because right now it is not solving for time. Okay, so you'll have to be able to rearrange these equations. And again, like in the last video, opposite operators, opposite bedmass. You try to get your unknown on top and then by itself. There are those two big rules, and once you follow those 2 rules, then you can solve all of these. Except for, I do want to point out that if time is squared here, and time is there, and time is squared here, and time is here, these are now quadratics. And although some of you may be in 20-1, the majority of you either are in 20-1 or in which case you may not have hit this equation yet, okay, or this unit yet, or you are going to be in it next semester. So the majority of you cannot solve quadratic equations and therefore cannot solve for time in those 2 cases. Now you can solve for time, however, if velocity initial is 0, because if velocity initial is 0, this whole thing disappears, and now it's a very easy quadratic equation to solve, and you can solve it. Also, if velocity final is 0, same thing happens here. So I do want to point that out because those are tricky questions, but they become much less tricky if velocity initial or velocity final are 0. And we will not make you guys solve a quadratic equation. There are ways to do it, but that is, that is a Math 20-1 concept, and hopefully you can take the course with me sometime as I explain that in depth. All right, let's continue on. So essentially, you list the ones you blah, blah, blah. I said that already. There are many examples of these different formulas above, but they can, because each one can be arranged in 4 different ways, since there are 4 variables in each of these equations. So if you think about it, there's 4 variables per thing, and there are 5 equations, so there's actually 20 different kinematic equations that you could solve for. And I'm not going to go through all 20 because that's just ridiculous. It's too much time. If you want to go over all 20, I'm sure there's plenty of other videos online that will do so, but I'm going to teach you the steps to solve any one of these, no problem. And actually, these steps are what I want you to be learning, because you're going to have to show me basically these steps if it's a written response question. So the challenging part is recognizing the values when they are explicitly stated, when they are not explicitly stated. Some things to look for in the word problem would be at rest, maximum height, dropped, or if it's giving some direction. That is super important because it could be positive or negative depending on the situation. So at rest tells us that velocity is 0. Keep that in mind, okay? That also means acceleration is 0. Okay, in which case, don't even do these. Do the constant velocity, do the uniform motion question, or formula. So it'd be V equals D over T. Do that formula instead for that one. Okay, maximum height. Well, if you are throwing something up into the air, when it reaches that maximum height, just before it starts turning and going back down, that VF will be 0. So I'm going to write VF as 0, but it depends. If it gets to the maximum height and now it's going back down, well, now we're talking about, so maybe I'll do two sides to this, two sides to the same coin. VF is 0, and then perhaps on the other side, over here, if you're talking about the second half of that, well, VI is 0. So it depends on what you're talking about, the dropping part, which we're going to talk about right away. So if you drop something, again, same sort of thing, VI is 0. So you're dropping it out of your hand. It starts off at rest and then moves from there. Sometimes we say that something started at rest. That would also just mean VI is 0. If the whole thing is always at rest, then it's different. But oftentimes we're just saying the first thing is VI is 0. Okay, and then again, the direction is important. So direction can tell us if it is positive or negative, and usually we say to the right, and to the north, and to the east are all positive things, normally is how we say it, and then all the negative things are west, to the left, south. I guess normally down is negative and up is positive. Okay, so that's nice to note as well. However, what I will say is those are generalizations. Even better than that is we say the direction of movement is positive. Direction of motion is usually what we call positive. So if something is moving to the right, we say that's positive. If something's moving to the left, we usually say that's also positive. Just that's how we normally do it, but it all depends on your frame of reference. And so this is how I will always do it. Direction of motion is positive. Okay, that's a better way to look at it than this. This is actually more of a Science 10 concept, which is helpful and nice, and you can use it, that's fine, as long as you're consistent, but better is if you say direction of motion is positive. Alright, let's take a look at this example question. Mr. Drager throws a ball up into the air with a velocity of 2.6 meters per second. It leaves his hand when it is 1.3 meters above the ground. Okay, so before you even keep going, you should really start thinking, hey, let's draw a picture because I want to make sure I understand this. So Mr. Drager is holding this ball and he throws it up into the air. Okay? And you can see that actually it starts off with a height. Right? And now it's going to get, I'm going to say h actually, and now it's going to get some new height added to that. Okay? So So now it says what's the maximum height it will reach. So let's just make sure we fully understand this. What is VI? Well, VI is when it leaves my hand, it's 2.6 meters per second. Okay, what is acceleration? Ooh, acceleration is negative 9.81 meters per second squared. Why is that? Because it's gravity. The only force on the ball is gravity once it leaves my hand. Okay, so I guess another thing to mention here is that A is 9.81 meters per second squared because of gravity. Okay, what else do we have? We want to know the height, so I'm going to just put a question mark there. And since it is a maximum height, that means our VF equals 0. Wonderful. So what we're going to do is pick the equation where which one is missing? Hold on. Where T is missing, right? We don't care about T, so let's find the equation where T is missing. That would be this one here in the middle. So let's try that one out. VF squared, hold on, equals VI squared plus AD, I think is what it is, 280. There you go. So that is the equation. Now, the question is, what is the maximum height it will reach? So we should rearrange this to solve for D. So first step here is that we're going to move VI squared over because, well, here it is. So our first thing is we want to get our unknown on top and then by itself. So this is the first rule. Okay, and the second rule is that we use opposite operators with opposite bed mass. Considering this situation, opposite bed mass means that we are subtracting by VI squared. Hopefully this makes a little bit of sense. We're subtracting by VI squared because it's adding here. Adding is the first thing on our opposite bed mass order. So this gives us VF squared minus VI squared equals 2AD. So far, so good. Just going to give us a little bit more space to work with. Okay, so hopefully that makes a little bit of sense. Okay, let's go ahead and try to continue to solve for D. So we're going to now divide by 2a to get rid of the 2a, and we're going to do that on both sides of the equation. So we're going to have VF squared minus VI squared over 2a equals D, because those have now canceled. All right, this is wonderful because now we can go ahead and plug it into our calculator. So let's do that right now. And again, the fraction button is very helpful. Some calculators you click alpha and then the y equals button, and then the first one there, and it gives you the fraction. That's the most common one to work. So if you don't have a fraction button that's labeled like mine, you can click alpha, y equals, and then press that fraction. Okay, so let's go VF. Now VF is 0, so I'm going to put 0 squared minus VI, which is 2.6 squared, over 2 times negative 9.81. So the direction of movement is up, so that's the direction I call positive, so that's why VI is positive. And then A is negative because gravity is down, so it's opposite of that. So anyways, here is our displacement. So our displacement is 0.34, I'll go 45 meters up. Okay, so if we stop there, we're really close, we're not quite done because we have to add the h back. Okay, so we're actually going to have to add h, so h plus d, right? So h is the 1.3 meters plus d, which is 0.3445 meters. And actually it is 2 sig digs, so it's 1.64. So the reason why it's like that is because this value here is actually 2 sig digs. So I could just fix that there, and now it will be correct. So that would be our final answer. What is the maximum height? 1.64 meters. All right, now the next part of the question, it's the same question, says, what is the velocity when it hits the ground? What is the velocity when it hits the ground? Well, now it's actually just that same ball went up into the air, and now it's curving back down, and then it's going to hit the ground. So the question isn't, well, the whole time, but the question is actually, once it reaches the top, it has a velocity of 0. So it's just the same, just a very basic ball drop question, where the direction of motion is down, so we can call that 9.81 meters per second squared. That would be acceleration. Okay, and VI is 0 meters per second because it's starting at the top, and that is starting at 0. VF is unknown, but it's actually being asked for, so that's good. T is also unknown, and D, is it unknown? No, actually D is from our last question where we had some sort of decimal answer like this. I don't want to prematurely round it, so 445. Oh, I did that wrong. There you go. 44546 meters. So now that we have done that, now we can go back and solve for VF. Now we don't care about time, okay, but this time we're looking for VF. It's actually going to be the same equation as before because we don't have any time. So we can reuse the same equation, but this time we're going to solve for VF. The nice thing about that is that it's actually really easy to solve for VF. All we have to do is square root both sides. Okay, the opposite operator of a square is to square root. So here it is. And so now we just have to plug it in our calculator. So we've got second function that. VI is 0 squared plus 2 times A, which is 9.81, times by D, which is 1.6445463812. You want to keep all the decimals and then round at the very end, especially when you got a square root or something. So 5.68, and we can probably leave it there. So 5.68 meters per second. And since we only have 2 sig digs at any point with a bunch of our numbers, actually, VF is not included. Actually, we only need 3 sig digs. We can go 3 sig digs because 9.81 and because our displacement has 3 sig digs. So actually, we can leave it right there. Always have to check the sig digs at the end, but that would be correct. All right. So I hope this video helps you guys better understand kinematics equations. The main concept here is you have to understand this opposite operator idea, where we've got opposite operators with opposite bed mass, where we've got our unknown on top and by itself. That's the goal. We're using these different equations with whatever is missing, whatever value is missing, that's the equation that we're going to use. Alright, I hope this video helps you better understand kinematics equations, and good luck!